let me introduce Dr. Tiansheng Yang. Dr. Yang is affiliated with University of South Wales, United Kingdom. His expertise are sustainable urban air mobility and smart transport system. He's specialized in electric vertical takeoff and landing, e-VTOL technologies, EV sharing system, and sustainable mobility solutions. Lead research on societal, technological, and behavioral adaptation of UAM in smart cities, innovations, policy, and high-tech diffusion. He focuses on integrating electric and autonomous vehicle within urban ecosystem. He examines innovation systems, behavioral adaptation, and public trust in advanced transparent technologies and research, leadership, and collaborations. Dr. Young's topic is urban air mobility that will be navigating the skis of innovation. So I welcome Dr. Yang. Please share your screen and please start your talk. Thank you.
All right, thanks. Let me share the screen. So hope everyone can see it. Oh yeah. Okay, use a slide. Swap this. Yeah, it's better. Okay, great. All right, so my name is Tiansheng. I'm the assistant professor from University of South Wales, UK, and I'm also a Wales ambassador in UK. And currently, I'm leading a journal called Journal of Urban Science with a special use issue on the urban air mobility. So today, my topic is more about the urban air mobility, which is exactly in the picture, electric vertical landing takeoff aircraft. And I think for the future transportation system, we definitely gonna have to think about it because this will shaping our mobility lifestyle. It will also shaping our mobility needs. So the first question is, what is UAM? What is urban air mobility? The quick definition is that we have road transportation, which is on the ground. We see the vehicles, we see the electric cars, we also see sharing cars and hailing service. In China, we use Didi. In UK, we use Uber. In Thailand, we use Ola. Correct me if I am wrong. And so we have multiple platforms for the shared vehicles or hailing services. But the UAM is more targeting in the air. So below 600 meters, what's going to happen over there is about a new transportation system. Is that we have to deliver our food by the Uber delivery by using the UAV. Is that we can use a passenger flying vehicle from A to B. So that's all about the UAM. It's a multi-stakeholder research, which is not only focused on artificial intelligence. Even in the future, we have AGI, artificial general intelligence. Even we have big data is supporting us. Even we have a lot of engineering, bioscience are working on that. It's about a multi-stakeholders. So if you are working in a social science research or pure social research, for example, economy, business management, operations, you can still work on the UAM because it's quite multi-stakeholder research. So today, I just show a little bit from a theoretical based presentation in terms of UAM. So can you see this slide, which is called Evolution of Transportation Paradigms Towards Smart Mobility? Is that clear? So am I sharing my screen? I'm sorry, host, could you double check please for me? Because this is quite important.
Yeah, Dr. Yang, your screen is visible.
Yeah, you can see it, right? It's
Yeah,
evolution. Yeah, that's
yes,
perfect. That's great. So
we can see.
this is this framework is thank you very much. This framework coming from my recent publication in terms of smart mobility, which is not only focused on the UAM, but in the general smart transportation system. So the basic of this theoretical framework is building on the transition theory, which is written by Gales 2002. Correct me if I'm wrong. And we have three layers here. The first layer is landscape level. Second layer is regime level. The last layer is niche level. So let me just clarify this transition theory in another way, make it you have a better understanding. Is that we know Apple. I think the majority of you also know are familiar with about the Nokia. Okay, so when Nokia becomes a mainstream, it's a regime level. Okay, at that time, I think about 20 years ago or 15 years ago, and that time Apple is on a niche level. Okay, so the majority of the users on the market, whether it's in China or whether they are in UK or in other countries like America or Asia, the majority of people are using Nokia. I can remember it's called Nokia number N97 or N95. And Apple is still on the niche level, so below Nokia, less market share. And a few years later, Apple created a new kind of understanding of the screen. It's touch screen without button. You don't have to press any button. You just touch the screen to make any of the activities you want. So Apple jumps into the regime level, which can share some of the market share with the Nokia, and the Nokia falling down maybe to the niche level or just disappear. So the regime level is the mainstream in this market or in this paradigm. The niche level, sorry, the niche level can be for the terms like new innovative technologies, startup companies, something like that. And the first one, landscape development, landscape level, is more about in the external environment, in a macro philosophy, macro level, what is the policy? For example, the SDG policy is widely being used and applied in different countries or different institutions. And in the COVID-19, we will see a lot of COVID as a scenario, which is an external environment, which can be understanding as a landscape level. So transition theory have three layers. So you understand the three layers is from the macro to the micro. Okay. And what I want to focus to discuss a little bit here is about the transition framework have a insightful lens on the transportation systems evolution. Okay. So around 1990s, or let's say 1980, okay, 1980s, mobility is still, or 1990s like that. Mobility is still the context in China. It's going to be more clear. Mobility at that time still a public service with few vehicle ownerships. So very few household have a car on a car. The majority of the citizens they are using bus, bikes, and walking that time. So I remember bus is quite cheap that time. It's 1 CNY. And later on, after 10 to 20 years, maybe, or 15 years, public transportation service combined with vehicle ownership. So a lot of households are having the vehicle ownerships. Okay, it's quite increasing, dramatically increasing in China. That becomes mainstream. And now around 2020s, if I may. Now it's 2026. So we have electric mobility as system as a kind of business paradigm that we have a lot of electric cars and a lot of electric vehicles can be shared. They have a lot of platform which is doesn't need a driver, so you drive yourself. You scan and you drive yourself. And a lot of smart mobility business ideas come up. And this kind of evolution needs to be engaged with multi-stakeholders. So it needs stakeholders collaboration. So this is how the general transportation system evolving in a Chinese context. Okay. And currently I'm working with some UAM companies. It's quite famous of the world. And I want to introduce some of them. I haven't fully collaborated with. Is that let me just describe the history of the UAM currently. Okay, so from 2016 to 2024, it's a rapid acceleration of UAM. It's happening. So in China, we call it low altitude economy. Correct me if I am wrong. And in UK, we call it UAM. and there's a lot of nice policies and grants supporting these activities. So leading innovators in this sector, in this UAM paradigm, in China, we have Yihang, and we have Autoflight, we have Unioncraft, and in Germany, the Volocopter is quite famous. I started working with them since 2015. They are quite, a reputable company because their original business and focus is on aerospace. And also auto flights, I'm working with them because they are more focusing on the heavy cargo plus the passenger vehicles. And they also have separate companies in Germany as well. Joby Aviation is from US, very good company. For their expertise is a long range of electric flights. So the technologies here, which we require, is artificial intelligence and autonomy, because I'm hoping the AGI will come up soon, so it will solve a lot of issues. And currently, the LLM and SLM, these large language model and the small language model, they are leading the mainstream. But in the future, maybe we will have the AGI will solve more problems. It's going to be more friendly as for the academia like us. And also we need the battery advancement. There's a lot of company focusing on the main problem, which is called range. If we can have a longer range, which is not only for the flying vehicles, also for the electric cars, will be much better. So the petrol and the diesel can have a supplementary product to support. And lastly is the digital airspace management. So imagine you have passenger flying vehicles in the sky, which is below 600 meters, and you also have those UAVs are flying, delivering the parcels, delivering the foods. If you order from the Uber delivery, it's gonna be a little bit chaos. So digital airspace management is quite important for the operational level. Okay. Lastly, smart mobility is no longer a vision, it is a vertical liftoff. All right, now it's a UM stakeholder ecosystem map. So on the left-hand side, I just categorize some stakeholder group. So firstly, we have OEMs who are providing and producing these flying vehicles, avatars, UAVs, whatever. And we also have some tech firms which are focusing on artificial intelligence, autonomous driving, and the big data services. These companies are quite important. And also we have other technological companies. Also, we need the support from the government who can integrate more resources, make this paradigm more firm. And we also need the support from the transportation operators and regulator, because I can still remember the insurance company or the policies on the UM still a big research gap, even a practical business gap, because if you have a flying car, so what level of insurance you may purchase. It's not only the personal driving, it's not only about the current commercial based price. It will be a little bit more expensive, depends on your reliability, depends on your technology, depends on your company reputations. There's a lot of things we need to think about. Also, the public acceptance, social acceptance is quite important. All right, so let me just introduce several projects I'm working with Auto Flights, which is passenger avatars are focusing on the air taxis or Airbus. So we focus on the number one, business model innovation. Number two, users preference and attitude is quite important. It's also a research gap. And also the UAM ecology. So within the UAM ecosystem, how many exactly stakeholders we should collaborate with are very important by integration. And the second project is Unioncraft. They're more focusing on the cargo. They're focusing on the firefighters. They're focusing on the forest detecting. So we are more focusing on the LCA. So UM solve not only the traffic jams, not only the emissions, but also make the transportation becomes more sustainability, that which SDG climate change are focusing. So one of the purpose we work with them is focusing on the life cycle assessment LCA. So compare with the vehicles, does the avatars produce less emissions? Does avatars is more sustainable? So this is quite important. The last project working with the Chinese hospital, we focusing on the emergency medical service for the traditional medical helicopters, driven by the aerofuel. So it needs a 30 minutes preparation. It has more and more restriction on the landing infrastructure, but avatars will help these problems. So one traditional infrastructure for the rescue helicopter can have 4 or 5 avatars, and avatars don't need 30 minutes preparation, so it will help the public health service providers to provide better service, to save the people's life, to rescue the very important golden 30 minutes. Okay, lastly, the ecosystem innovation strategy is that I put some reference here for feel free to take over. And we have some ecosystem element, which is on the left-hand side, we have stakeholders, and we have policy and regulations, public perceptions, trust, safety, for example, awareness, attitudes. And the next network infrastructure, this is also very important. It's not just a company can do it. It needs everybody's involving and support. And technological innovations, operations and logistic for the aerospace management, consumer demand. Is there any demand in the market? So it not only become a very pure public. It's gonna be a pure public services, and it's also have business models over there. So there might be a profit, must be a supply and demand over there. And sustainability and emissions, innovative business models, equity and accessibilities. These are the ecosystem I'm working on currently. So it's a lot of things. I'm very happy to work with you. And if you have interesting, just let me know. Smart of mobility, the role of AI. AI has a very huge impact on the smart mobility nowadays, not only developing the autonomous driving technologies. I work for the Bosch Systems, chassis systems. We are focusing on the level 4 and level 3 autonomous driving. Now it's more about level 4 in a practical, empirical way. So I'm sure the artificial intelligence is very important because with a lot of road data, how are you going to deal with? Of course, you're going to use machine learning, you're going to use AI technology to train the ESP system, or for Tesla, it's the FSD. And lastly, we work with the Holly UAV. In Chinese, it's called Hanlai UAV Ltd. In English, it's Holly UAV Ltd. And they called Holly UAM Ltd currently. So we also have a very close collaboration with them, focusing on the social science-based research, which is sustainability, LCA, and efficiencies, and also SDG problems to make their product, their company become more sustainable. Thus, their company's future is going to be more sustainable. When they produce the product, they will think about sustainabilities, they will think about LCA's emissions, rather than we just produce the avatars without thinking of protect the environment. Lastly, this is my current research, and it's a giant picture. It has the closed loop of a life circle of a produce or of avatars. So increase a very practical data and quantitative data based how much emissions if for avatars can create from the beginning to the end. So this is quite interesting for the LCA project. And lastly, I'm the editor of leading editor of the special issue of Journal of Urban Science. The special issue is all about the sustainable urban air mobility and intelligent transportation system. We welcome multi-stakeholder researchers. If you're focusing on the sustainable urban air mobility, whether it's social science, whether it's education, whether it's management, we are very welcome you. And lastly, thank you very much. Any questions? I'm happy to answer. Yeah, please go ahead. Thank you. Sorry.
How is the battery redundancy and emergency backup managed to ensure zero failure during critical missions?
Could you repeat that question? Sorry, I can't hear clearly. The battery efficiency, is that what you mean?
How is the battery redundancy managed during critical missions?
Okay. This is quite important, interesting question. Thank you very much. The battery management is more about it's what I'm researching for the electric vehicles actually. For the UAM, currently the majority of the company cannot solve the battery problem, like you said, reduce that. It's really hard for them to do it. So the majority of the passenger-based eVTOLs, they are not fully electric. They are more hybrid or plug-in powered system. So you can still charge them. They can still use the electricity to run the eVTOLs, but they will also have fuels to run it. It's more like a hybrid system.
Yes, it's clear. Thank you.
Thank you. Thank you very much. Okay, so any other questions? I'm happy to answer. Even with a special issue, if you're interested in for the Journal of Urban Science, just let me know. Otherwise, I will hand over to the host. Thank you.
If there are any questions, they can raise their hands.
One question actually. Hello.
Thank
Hello.
you very much. Thank you very much. Please.
Hello.
Yes, I can hear you. I can hear you very clearly.
Okay. How it
Yeah.
can be actually transforming LCA? Can you explain that?
Is that the question about life cycle assessment, LCA?
Yes.
Okay, so how I do LCA, right?
Uh-huh.
Yeah, that's perfect. Amazing. Thank you very much. So triggering the LCA will be a little bit problematic. What I do is that you need to have a very strong collaborators, a company who are willing to work with you at the research project. We call it AR, like actional research, whatever. So we let them produce, for example, Excel sheet to record all the emissions and all the things they've done from their side. For example, how much they spend for the electricity. Where are the electricity of the company coming from? Is it solar power system or natural resources wind system, or they purchase the electricity from the normal way? Okay, this is kind of first step. How the company use electricity is this natural resources. Secondly, is the raw materials of these eVTOLs. Where they get it from, so we can have a traceability. It can be traceable. It will be a kind of a traceability issue. We can know what exactly emissions can be calculated from the raw materials. And secondly, how about hybrid system? The efficiency, we will utilize all of these data and calculate the LCA from our side. It's a little bit complicated, but we want to consider everything, including infrastructure, everything. So how much emissions per eVTOLs can create. Thank you. Is that good for your question?
Yes. Thank you. Good.
Yeah, pleasure.
Thank you, Dr. Yang.
Thank you.